Hey folks, welcome back. In this lesson, we're going to talk about deployment strategies for CloudFormation. And we've already deployed a CloudFormation template in the previous lesson, albeit a simple one. But we're going to talk about more deployments with CloudFormation and also how CloudFormation can interact with other services such as Elastic Beanstalk, OpsWorks, and Puppet. And the type of deployment we will ultimately perform depends on our requirements. So when considering CloudFormation deployments, we need to look at deployment methods, environments, requirements, time, cost, application, and the life cycle of that application. Now, one of the key features of CloudFormation is the ability to bootstrap applications, and we would do that using helper scripts. So these CloudFormation helper scripts can install, configure, and even start applications on EC2 instances. So this is a really helpful feature in that you don't have to use any other tools, and it's pretty much all self-contained within CloudFormation. So the helper scripts are called directly from the CloudFormation template. And these CloudFormation helper scripts are CFN init, CFN signal, CFN get metadata, and CFN HUP. Using these helper scripts, we can do things like install and update packages, start and run services, add, modify, or delete users and groups, as well as permissions for those, move, create, or delete files and directories, and configure or restart services such as Nginx, Apache, and many more. Now, it's important to know that these helper scripts exist and can be used to deploy applications, but we will look into these in greater detail in upcoming lessons. Now, when you start bootstrapping applications, these things take time, so there's a time and timing element to all of this, and it's something that needs to be considered up front. So when considering all of this, we may need to find ways to speed up the deployment process. And one thing we can do is pre-baking AMIs. Pre-baked AMIs can have a significant portion of the application already installed in the base image. So this can speed up our bootstrapping, gives us fewer actions to perform, and it will reduce the time it takes to prepare an instance. Typically, as we saw in a previous learning activity, pre-baked AMIs can be used with auto-scaling. Now, for bootstrapping, there are also security considerations. Storing sensitive information in a template is not recommended. So how can we get around that? Well, we can use the no echo property, set it to true, to hide sensitive information. Now, another thing we can do, instead of hard coding the sensitive information in a template, we can use parameters. So the sensitive information will be created during stack creation, and we can retrieve that information using parameters. Now, another consideration with bootstrapping is that we have to rely on updating our stacks through CloudFormation, and this can cause issues with certain resources. Now, thinking about an auto-scaling group, we would not want to update all of the instances in our auto-scaling group at once. This would cause downtime. So what we can do is perform rolling updates on our auto-scaling groups, and we'll look at this a little later. But the rolling updates can gradually roll out new instances while removing older instances. So using this technique, we can avoid downtime. And the technique to do this is to define an update policy in our template. Now, another thing we can do with CloudFormation is use CloudFormation with other services, such as Puppet, OpsWorks, and Elastic Beanstalk. So let's focus on Puppet first. We can deploy Puppet with CloudFormation and let Puppet manage and configure our infrastructure. Now, the technique would be to use CloudFormation helper scripts to deploy Puppet. Puppet is an open source platform used to provision, configure, and patch applications as well as operating systems. Puppet deployments have master and client nodes. The Puppet master is a centralized server that holds instructions and definitions. So the Puppet clients connects to the master to download instructions, and those instructions define what to install, update, and patch. So the key feature is that Puppet gives us configuration management and ensures the state of our instances. And here's a key point to remember. Using Puppet is great for applications that have a longer life cycle. With applications having a longer life cycle, the situation is going to arise where you're going to have to push updates to your application. So when we need to do updates, we don't want to throw out our whole environment, but we have to be sure that the state of our instances and applications is consistent throughout the environment. And that is a use case for Puppet. And remember, for the DevOps Pro certification exam, we want to be thinking in use cases. So in this situation, Puppet gives us a central control center to update our applications. And that central control center is the Puppet master. And again, then all of the client nodes can grab those instructions from the Puppet master. So in a sense, Puppet is performing the role of your CloudFormation helper scripts. But for this particular use case, it's better suited than the helper scripts. Okay, now let's talk about using CloudFormation with OpsWorks. OpsWorks is a configuration management service that uses Chef. So in this situation, Chef is performing the role that Puppet would. The difference being is that OpsWorks is integrated with the AWS environment. So to build our environment, we can model different layers in OpsWorks that define resources and software configurations. And we have an upcoming section on OpsWorks, so we will certainly get into more detail on OpsWorks. OpsWorks has dynamic configuration, which makes it suitable for applications with longer life cycles. So we can use CloudFormation to manage our OpsWorks resources while using OpsWorks to configure software, deploy applications, scale the environment depending on demand, and monitor resources for performance, security, and cost. Now, before completing the discussion on OpsWorks, let's just go ahead and take a look at this in action. So I'm going to go into CloudFormation, and I'm going to create a stack. AWS provides a sample template for OpsWorks. We'll go to Browse Sample Templates, and there is OpsWorks. All right, basic AWS OpsWorks stack creates an AWS OpsWorks stack, layer, instances, and associated resources to run a PHP application. Now, let's view this in Designer, and I will just expand. All right, let's take a look at our template. So we have mappings for our regions, resources, OpsWorks stack, and OpsWorks layer. And note, this is where the PHP app resides. And OpsWorks instance, T2 small, the OpsWorks app, PHP, a service role, simply an IAM role, a policy, an IAM role for the instance, and an instance profile outputs, stack ID, and application ID. Fairly simple. So again, we're using CloudFormation to manage these OpsWorks resources. So we're going to have a CloudFormation stack. And if we need to update these resources, we would do it via CloudFormation, such as an updated template. All right. So let's validate our template. Template is valid. Let's build our stack. Click Next. Stack name. Next. And we don't really need to do anything with options. Next. And acknowledge. And create. All right. So it's creating our CloudFormation stack, and it's starting with IAM roles. And this will take a little bit. So let's continue with the lesson. So what are the benefits of this type of deployment? OpsWorks is better suited for longer deployments, not so great for shorter deployments. OpsWorks provides a higher level of abstraction, making it more convenient to deploy certain environments with less work. Whereas if we just used CloudFormation, there would be a bit more work. CloudFormation has resource types for OpsWorks, and we've seen some of that. OpsWorks layer, OpsWorks stack, OpsWorks instance. We've seen those. OpsWorks app, OpsWorks elastic load balancer attachment. Well, let me go over and check on our progress on our stack build. Bunch more events. Creation complete on our IAM role. Instance profile. OpsWorks stack. OpsWorks app. The OpsWorks layer is built. And it's working on the instance. All right, back to the lesson. Okay, now we're going to move on to using CloudFormation with Elastic Beanstalk. So I'm going to click on Key Concepts. So again, similar to using Puppet or OpsWorks, so we can use our CloudFormation templates to kick off our Elastic Beanstalk deployments. Now, through Elastic Beanstalk, we can configure how we want our deployments to be performed. We can do all at once, rolling deployments, rolling with additional batch, immutable deployment. This can all be configured from Elastic Beanstalk. And this can help decouple our environment. We can integrate Elastic Beanstalk with other services like RDS, S3, DynamoDB, without having to throw away these important resources, because ultimately it's all going back to our CloudFormation template. That's where everything originates from. So what are the differences in using Elastic Beanstalk with CloudFormation versus using OpsWorks with CloudFormation? And again, for the DevOps Pro certification exam, it's useful to think in terms of use cases. Now, Elastic Beanstalk with CloudFormation doesn't allow us as much flexibility for some configurations and deployments. And this is very key. It is more suitable for shorter application life cycles where an environment can be thrown away with each deployment. Try to commit that to memory. That's the type of requirement that you will see on the exam. And that is where you will make the decision between Elastic Beanstalk and OpsWorks with CloudFormation. Elastic Beanstalk makes a lot of decisions for you. OpsWorks can be more customizable. So that's another key difference. And it's something you want to commit to memory and know the difference between these two. And it will help you make a decision when taking the exam, and equally as important, on the job. Now I want to touch on code services with CloudFormation. We can use CloudFormation to provision the infrastructure and then deploy and manage applications through services like code deploy, code commit, or code pipeline. So we've looked at pros and cons for using different tools for deployments. But when does it really make sense to use one over the other? We need to look at deployment methods to make a more informed decision. And two methods are in place versus disposable methods. In place performs upgrades on existing resources, such as EC2 instances. Disposable, on the other hand, rolls out a new set of resources and removes older ones. In-place upgrades are generally faster because we don't have to wait on new resources and can be used with applications that don't keep sessions. Now, the disposable works well with immutable infrastructure and blue-green deployments. In other words, we just completely replace the resources. To summarize, for our in-place deployments, let's think about using OpsWorks and Puppet. So for our in-place deployments, OpsWorks and Puppet are great choices. Now for the disposable, Elastic Beanstalk and CloudFormation are better suited for this, although OpsWorks and Puppet can be used. And for the disposable upgrades, we can do blue-green deployments, and there will be an upcoming section on blue-green deployments, so we'll go into much greater detail. And our timing is perfect. We're wrapping up this lesson, and the build of our OpsWorks stack has just completed. Let's go over to the Management Console, and the build of our OpsWorks stack using a CloudFormation template has completed. It took roughly 15 minutes. We have a CloudFormation stack, and inside of there we have an OpsWorks stack, OpsWorks app, OpsWorks layer, and instance. So again, there's going to be a whole section on OpsWorks, but let's just check it out. We'll go over to OpsWorks, and there we go. There is our OpsWorks stack. There's our OpsWorks layer, and there is our OpsWorks instance. So with this, we are well on our way to managing a PHP application using CloudFormation and OpsWorks. So with that, we have completed this lesson. So go ahead and mark that complete, and let's move on to the next.